In this video, let us see about the transshipment, one more case where we need to add the buffer. So we'll start with a simple problem, then we'll understand where and how to add the buffer for which nodes. So as you can see here, we have two sources and two destinations. And the source, the supply is 350, the total supply 100 and 250, 350. And with the destinations, we are having the demand as 200 and 200. So here, if you see the demand is greater than supply, and the respective cost of the path is given 5, 8, 9, and 4. So let us see how to solve this using the LPP model in Excel. Then we come back to our Excel. So in this case, we have demand is greater than supply. First part. Yes. Then we have source as S1, S2. Then the demand is D1 and D2. So we are using the matrix form how to solve it. So if you don't know what matrix form we are using, just check the previous video. In S1 to D1, the cost is 5. So 5. From S1 to D2, the cost is 8. From S2 to D1, the costs are 9 and 4 respectively. So 9 and 4. So now we need to know how much quantity is passing through which paths. Just copy them, paste it. These are your variables. Just make them 0 and 0. Now you're calculating the LHS, which is nothing but the auto sum. So what is the sum value here? How much of the goods are coming from S1? So that is your sum. Just adjust them. Then get this. Again here, just leave one cell always. It is easy to identify what are your LHS values. Again, do the auto sum, two values. Then we have selected. So what is this LHS value? So these values are the variables we how many tons have to pass from which source to which destination. This LHS is giving what is the value of the total goods coming from S1 and S2 respectively. This value is giving how much, what is the value of total goods received at D1 and D2. But how many have to receive and how many can move is your RHS, which is nothing but your constraint. So S1 can supply a maximum of 100 and S2 can supply a maximum of 250. Similarly, D1 can take a max of 200, D2 can take a max of 200. In this case, as I have mentioned previously, demand is greater than supply, which means we cannot satisfy the entire demand. Whatever is in the supply, we try to send it all. Whatever is in the supply, we try to send it all. So at S1 is 100, S2 is 250, which means the goods which are leaving from S1 is equal to 100. Why? Because we are trying to send the entire goods which we have in the supply because demand is greater than supply. So every distributor or manufacturer would want their entire supply to move out if there is demand. Again, equal to 8 RHS in the demand side. So demand is 200 and 200 respectively. So 200, 200. Here, demand is not met. We know demand is not met because total supply and total demand are not equal. So we don't know where the demand is not met. So we give that authority to take the decision where it will not be met to Excel solver. Why? Because we don't know it either D1 is costly, D1's path is costlier or D2's path is costlier. We don't know. Thus, we are saying to Excel solver that you can make them less than or equal to. But since the entire supply is utilized, it will use the entire 350. But it will assign to those nodes where the ultimate cost is less. So finally, we construct our objective function, which is nothing but the cost into the paths, some product of all the cost associated into the quantity which you are shipping through the path. So this part is clear. Here there is no buffer and all. This is just a simple case. We'll get the buffer in the next part. Same continuing in the same video. Come to data, solver. Just reset all. Then this is your Z. Well, objective function is Z. You want to minimize it. Changing these four values. The constraints are these two. Are equal to. Then RHS, these both are equal. Add then these values are less than or equal to. Okay. Simplex solve. Solver found a solution. So as you can see, the demand at D2, entire demand is met. There is no slack here. Entire demand is met. And you can also see here, entire supply is used. Whatever the supply, entire supply is used. Entire demand at D2 is met. Entire demand at D1 is not met. Obviously, we know that entire demand can't be met because there is no enough supply. Yes. But the entire demand for D2 is met because, as you can observe, the cost from S2, the cost is 4. So S2 has a supply of 250. The entire 200 which can be sent has been sent. The remaining value of 100 and 150, remaining 50 value are sent through this path. Yes. That is done. This is a simple case. We understood how to solve it. If then the next part. So now when we'll come to the diagram. Here if you see, there is no path to come between S1 and S2 or between D1 and D2. What happens to the same case if a path comes between them? That is, you obviously know that from the destination you will not be sending it to source. But what if there is a path which is coming in between them, in between source S1 and S2? Suppose there is a path from S1 to S2 and there is a path between D1 and D2 and the cost is 2 and this is also this path to go this way. There is one way cost is 2 and here one more cost. This also let us say the cost is 2 for this also, but here let us assume there is no cost. You can also add cost, that is not an issue. But just to understand, we are adding 0 as the cost. Now what has happened? You don't have a single source. You have 4 sources now. Because all the nodes can be the source node for some other thing. S1 is the source for D1, D2 previously, but they are also source for S2. S2 is source for D1 and D2, but it is also source for S1. D1 was previously not a source, but now D1 can also send goods to D2. D2 has also become a source. Now that also can send to D1. Let us see how to put it in Excel. The same way there is demand is greater than supply. Here, what are our sources? As we have, let us, I use it here. So it is easy to compare. So here we have 2 sources, but here we have 4 sources. S1, S2, D1, and D2. All these values are your sources. What are our destinations? Initially, D1 is a destination, D2 is destination, but S1 is also a destination, S2 is also a destination. How? For S2, if it is using this path, then S1 becomes a destination. For S1, if it is using this path, then S2 becomes a destination. Yes. So those are also our destinations here. Now let us put the cost. This cost is the same, that did not change. S1 to D1, the path is same 5. S1 to D2, the cost is still 8. So 5, 8, 9, 4. Then this is 9 and 4. So when you are doing these problems, first fill those values which you already know. Then S1 to S1, as I already said, the cost is 0. S2 to S2, the cost is also 0. Similarly, D1 to D1, the cost is 0. And D2 to D2, the cost is 0. Now, once if a goods are transported from S1 to D1, will they go back to S1? No. Once you're getting them from S1 to D1, they will not go to S1 or to D2. Yes. They may go to D2. S1 to D1 is possible. D1 to D2 is possible, but D1 to S1 and D1 to S2 are not possible. No. So there is no path and it is not possible because once the goods are delivered, they will not go to the initial source or the primary source. Yes. So there is no such path. So we eliminate that path. So how to eliminate that path? By increasing the cost. So from S1, from D1. So D1 is your source. D1 to S1, the cost is 1000. Similarly, D1 to S2, the cost is 1000. D2 to S1 also the cost is 1000. D2 to S2 also the cost is 1000. Now, S1 to S2, I said there is a path. S1 to S2 the path is 2, S2 to S1 the path is also 2. So 2 and again 2. Now D1 to D2 also we have considered the path. Here we have put the cost as 0. You can also put some other cost, that is not an issue. Let me put 0 and 0. So this part is how we have constructed when all the four nodes become the source and all the four nodes become destination. Now this is the cost. Now let us check how the goods should move from one node to another. Entire goods shifted will be 0 because these are our variables which Excel solver will find out. Then now this will be your LHS. Always do those steps which you already know. LHS, this is symbol, then RHS, then again RHS, then your objective function, which is Z, which is nothing but sum product of cost and the goods which are shifted. Yes. Just so these both are comparable, let me delete some rows. Yeah. So now the two cases are clearly visible. LHS is nothing but your auto sum, which is the sum of the total goods which are shifted. So the auto sum of the goods, then extend it to the remaining four destinations. Similarly over here, which is the auto sum, then extend it. Now when you come to RHS, you know what RHS for D1 and D2 is. 200 and 200, that is the demand. So just put 200. Here also 200. You don't know how much should come for S1 and S2. What is the quantity that should reach that? This is because these are destinations. These are the sources. So we have seen earlier also. Sources are this way. Destinations are these. These are destinations. If the node is here, it is acting as a destination. The node is there, that is acting as the source. So the values which are to be received, which can receive here, as per the initial part of question, we have written D1 can receive 200, D2 can receive 200, S1 can supply 100, and S2 can supply 250. Now, with what values can we equate these two, this cell and this both of these cells and both of these cells? So we don't know how much can come here S1 and how much is leaving. This is the destination. How much can come to S1, how much can come to S2, how much is leaving from D1, how much is leaving from D2. Because as you can see in the diagram, from S1, maybe 100 are leaving from here. They are coming to D1, then they are coming to D2. We don't know how much is coming from S1 to D1 and S1 from there again to D2. Similarly, we don't know from S2 what is coming to D1, how much is coming to D2. That value and all are not available to us. So here comes the concept of buffer. Why buffer is coming here is, here we are having all the nodes, whatever the nodes are existing here, they are acting both as source and a destination. In such a case, the goods which are shipped from one location to another, the quantification is not possible to do for us very easily. Since here it is a simple problem, maybe we can sit for some time and do it mathematically also. But for long nodes and long situations, that is not possible to calculate. There we add this value buffer, which is nothing but maximum of supply and demand. This value gets added to all those nodes which are acting as intermediate nodes. That is a simple rule to identify. If a node is an intermediate node, then add buffer. So before knowing what is an intermediate node and all, you need to know some terminology. Suppose, so here, let me see a new one. Yeah. So from this thing, this is, suppose I assume this is one node. So this is one node. This is one more node. And this is one more node. There is a path to move from here to here, here to here. and here to here, and again here to one more node. So this is called as primary source. Primary source node. Just bear with my paint writing. I'm not so expert in this. So this is your final destination. Final destination. Because why are we calling the node? So I'll just name them. Let us call this maybe A, then B, then C, and then this as D. So A is your primary source node because A doesn't have any other source. No other origin or no other connection to get nodes, get material from somewhere else. A is the primary location where your goods are starting their journey. B and C are called as intermediate nodes. Both B and C are intermediate nodes because they are neither primary nor destination. D is called as final destination. You can call B as a destination node. C is also a destination node, but D is the final destination node. So what nodes are here intermediate? Only B and C are intermediate. A is not intermediate and D is not intermediate. But if you see in the previous case, so let me just open the diagram. Yeah. So yes. You see, in this case, we have drawn it. There is a path from here to here, then there is a path in between. There is a path here, there is a path from here, then there is a path from here. There is one more path here, there is one more path in between, and there is one more path here. Here, what is the primary source? S1 and S2 are sources, but they are not primary sources because S2 can get from S1, S1 can get from S2. Similarly, D1 and D2 are not final destinations because they also are acting as source nodes. So as long as they are acting as intermediate nodes, all these nodes will get buffer as addition when all the nodes are acting as both source and destination. So here, what is the buffer? Maximum of supply and demand, which is nothing but here the demand. Demand is 400 and supply. Supply is 350. So maximum of that is 400. I said add buffer to a node if it is an intermediate node. So we have found out that all the four nodes are intermediate because they are neither primary source nor final destination. So they are intermediate nodes. So we add the buffer value, which is, this implies buffer value is 400 because it is maximum of both supply and demand. So for all the nodes we are going to add, means here we are going to add plus 400 existing value. Here also we are going to add plus 400 to the existing value. So this will become 600, 600, 400, 400. Then this is 500. This is 650. This is 400. And this is 400. Now what is your entire source? It is 1950. You can see the sum in the bottom part. 1950 is the entire source goods that can move. What is the entire demand goods? 2000. So the symbol should be equal. Use up the entire source and try to meet the demand. So demand is less than equal. The same case, demand still is greater than supply. So use up the entire supply and try to satisfy the demand. That's why we are using the symbols equal to and less than equal to. Then let us solve it. Data solver, reset. This is your objective function, minimize it. Variable cells are these four conditions. Then second constraint, second set of constraints. Simply okay. Simplex solve. Solver found the solution. So if you can see, S1 is using up the entire buffer and S2 is also using up the entire buffer. The buffer is nothing, but there are no actual goods. Actually, there are no extra goods. This 400 we are only adding so that this mathematical loop which we have created in terms of the path, that is satisfied, and there is no loop function, there is no deadlock loop, means there is no, Excel is not trying to run over and over again. It has to break at some point with the loop. So the imaginary goods are being transferred, but actually if you see from A, 500 and 650, if you remove it, how much? 400 is a buffer, so 100 and 250 has moved from A. And how much did you reach at D1 and D2? 400, if you remove, 150 is reached, and 200, the same values are reached, 150 and 200, 550 and 600. But now see at the cost. You may get the doubt, if the same values are being reached there and here, why are we doing it? See the cost. Here the cost, in this case, the cost is 1750. In this case, the cost is 1500. You might say that the path, the cost is less and something. Since the path cost is less, that's why the path have come into occurrence. Because if you actually have found some path in real life scenario, if at all there is a path between two sources, actually the cost is less or relatively less when compared to these four, we'll try to use it, but we don't know which path to use and how much quantity to move. There is where we use Excel solver to solve the problem. That is why we are adding buffer. So one simple rule to add a buffer, always remember the diagram. If it is an intermediate node, only then we add the buffer. If it is not an intermediate node, we don't add the buffer. You, when a node is called as, when a node is not called an intermediate node, either it should be a primary source. Only in two cases you can call a node as not an intermediate node. Either it should be a primary source or it should be a final destination. Only in these two cases it is not an intermediate node, else the node is always an intermediate node, as in this case. Because these nodes are neither primary sources nor final destinations. Why not final destination? Because from D1 it can come to D2, from D2 it can go to D1. So they are not final destinations. These are not primary source because from S1 goods can move to S2, from S2 goods can move from S1. So in the next video, we'll see one more problem on the same buffer concept.